So, welcome to Google Attention Developer Community in Nairobi, and we are
Thank
very
you so
much
much.
grateful to welcome. Yeah, so maybe you can get to introduce yourself to the community so that we can be able to get to know who is Eliana. Welcome.
Oh, thank you. I am from Brazil. I am agronomist and professor here in the Federal University of my state. And I live in the most southern state, so here is not a tropical area. Besides, stay in Brazil, and I am. Google Developer Expert in Earth Engine category. This is a new category, and after everyone who have uh, who share the knowledge in the Google Earth Engine are welcome in our category. So I think that's it.
Yeah, that's a good with us. Yeah. So, welcome. Now the time is yours. You
Thank
can
you.
take us through. Yes.
Okay, so I will share a screen.
Yeah, you have the privilege to share.
Uh, yeah. So uh, Nicholas asked me to talk about agriculture in Earth Engine, so I will talk about a little about Earth Engine and about agricultural analysis using satellite images. And then we see some aspects inside the Earth Engine. Uh, well, Earth Engine is not only a repository, is more than a repository because we can analyze the images using algorithms that are implemented in Earth Engine and use the power of the Google Cloud. And Earth Engine is free for everyone, uh, but is only to research and as a teach tools. Uh, for commercial use, we need to pay, but for the startups can apply to Google support in the beginning of their work. So a new user must register at this link, and then when appropriate, choose a no commercial user, and then we can use, but we don't. Sometimes we have a restrict space, or we can process all over the world. We need to choose a small area because we are in the free part of the Google Cloud. So the most of the users are using this interface in JavaScript. This is the name is Interactive Interface in JavaScript. And this is the start screen. And here we can see our scripts, here where the scripts run. And here we see some results, and in the map, another results. Okay, about the Earth Engine, if you need some help, I can help you after with the register if someone needs. Okay, about the agriculture. So, when we use remote sensing data to monitor the agriculture, we have two questions: where the agricultural fields are, and about the weather. How about the weather during the crop cycle? And Well, to monitor the agriculture, we need some concepts about the spectral reflectance. So reflectance is a part of the incident radiation. So it's the part of the reflect from the different targets. So here we have a graph, and we will do the same graph inside the Earth Engine. But water have a spectral reflectance different from vegetation, different from soil in each wavelength. And to monitor agriculture, we must know about spectral index. And NDVI is the most used vegetation index. And to understand the NDVI, we need to understand the spectral reflectance for different targets. So, but if we think only about vegetation, when vegetation is healthy and green, the NDVI is higher, and when the vegetation is brown, like in the end of the cycle, the NDVI is lower. Well, to see how the things works inside the Earth Engine, I prepare some scripts, 9 scripts, and we use two optical satellites, Landsat 9, uh, to see something in local scale, and modes to see something in regional scale. About the weather, I took the ERA 5, the analysis, and to take the where the agricultural fields are, we use the as a world cover, and to build a small app, we see the elevation model using SRTM. So, okay, in the Earth Engine, this if you take uh, this link, you can see the same scripts, and then I will show in by order for you. First I run, then I explain everything, then I run again. So this is the first one, is to define our study area, or define the border of our area. So inside the Earth Engine, we have many data sets. Here is the link of this data set that have features collection about all over the world. And this is organized in um, here I can show you. For each data set, we have some information, and here a small sample, and how the things are organized. So in the level zero, we are in the country borders, and we can choose other levels. Level 2, we are inside each country. So first, I select using the level zero here. So level 0 is the name of the variable, and then I use this command sorry, as Earth Engine, and in this variable I will put a feature collection, and this feature collection is here. And where is this snippet? Is here. Is the same. And then I filter using the name Kenya. Kenya. Ok. Então, here in this filter, filter equal add name Kenya is here. Add name Kenya. And then I draw using some options. So in variable Kenya, I have only Kenya border, and it's here. Only the Kenya border. Is everything okay? Hello?
Yes, it's okay. We can.
Yes?
Yes, we are following up.
Okay.
It's okay.
But the Earth engine is not okay here.
It's coming out.
Are you sharing something in Colab? Nicholas?
Yes.
Are you sharing something in Colab?
No, I do not have anything. You can share.
Well, okay, I will start in a new. Okay, I was talking about the border. So then I draw, add layer, Kenya, and I choose a center in the map center and as a satellite image as map options to start with this base map, not with this one. I can put here to start with the satellite, and then I draw the Kenya. And then I filter in list inside the Kenya using the administrative names level 2. So, and I put here to print my consult. So here in list, I can see all the Kenyan regions. And I put to draw here and here. Now it's okay. So these two layers is only to see how I choose how can I choose a border, but we can also put a shapefile here. If you have a shapefile, and we go to assets here, and then we create a new shapefile, and then you can upload your shapefile. Okay, well, now the second script I will run first, and then I talk. So here I will show you how can I choose Landsat image. So here in the first, I have a variable, and this variable is a shapefile that I upload before, and is how the Landsat images are organized here. They are organized in the lines and columns and have a systematic numbers. The numbers are path and row. So I put here Narok because I saw before that Narok is a region inside the Kenya that have many agricultural fields. So I put Narok, center the map in Narok here, and then I select the entire image collection of Landsat 9. And then here is the link to see the entire image collection. And then I filter my image collection by Narok borders. And then I choose cloud cover less than 5%. And I choose the 3 first months of this year. So I took the image collection and then I filter the image collection. And print here in console the number of images that I have after apply the filters, and also the list of the images, also the list. Well, but sometimes I have clouds in one part, but in my study area I don't have any clouds, and I can take the image. So here are the images, 3 images over Narok, and we can, I don't know why I have some problems here to run. I think now it's correct. Yeah, only six. And then we can draw the images here. Here. Oh, this one with no clouds. This one with clouds. I put the filter, but the filter, these clouds are less than 5%. So the clouds are here. And so we can see here many clouds. And in the other day, less clouds. So this code I made use lots of snippets that I will found. So here after we can use these snippets to draw a shapefile. So with this one, I draw the shapefile with those footprints that I showed you before. Here, these lines, black lines. Here, another snippet to write the pet row names. So this that the names that you are see here in red. Then another snippet to visualize the images. And here I will explain a little more the first two. To visualize all the images, we need to select the bands. In this case, for Landsat 9, B2, B3, B4, blue, green, and red. And to choose a minimum and maximum value that we can see all the images without with no contrast, no other manipulation. So this is minimum and maximum around 0.3 because the reflectance pattern in visible bands are very low. And if we put here one, the image, we cannot see anything inside the image. So in this snippet, to visualize the image, first I select the bands and choose the minimum and maximum values. And then I apply a function to display each image. So I took the ID from each image, and this is what you are seeing here in the name of the layers, and put select each image in this variable image, and then map add layer using this variable, these parameters that I set before, the ID, the name, and false. This false is I run the scripts, but the layer was not drawn before. I need to click here to see the layer. If I put here true, then the layer, after I run, the layer was checked. Then this snippet I found is this button, list selected layers. I can explain something, but I need, in fact, explain something. This kind of looping in Earth Engine is not used. The Google's, the developers, they talk to us to not use it all the time. I think that is because we needed some other levels of processing use to a loop, to make a loop in here in Earth Engine, we use map. But sometimes we use this kind of JavaScript pure, if I can talk this. This snippet will, because we are with the here, with the list, but which one is which one here? So we can put, select only that we want, this one, or this one. Oh, less cloudy, the second. Okay. Then for the up, this one or this one, the second. So these two list select layers. And then here in the console, we can see only that images that we select. And then we can copy this name to took only this image, and that we do in the next script. Okay, so this is a collection of snippets with this that I took and put together. It's very useful. Now is the remote sensing for agriculture inside the Earth Engine. So I will run and then I explain. So I took the image and select some points and made some graphics here. And then in this script, we will talk about spectral patterns of the reflectance. Okay, so first I center the map center. This is a point in Kenya, and here is the zoom level. The zoom level, how can I say the zoom level? Here in Inspector, when I click in any point, in the first, I can see here zoom level. So I can choose, I prefer that my map start in this zoom level. So, but now, what number I need to put here? So I click, and then I know here, zoom level 12. But in this case, I choose 7. Then I select only one image. Only one image. Which image? I choose using my script number 2, and then I select only one image. Here, image is for only one image. When we use a lot of image, is an image collection, and then the command is image collection. Then I select only the bands 2 to 7 here using this command. And then I put to draw map add layer, the same minimum and maximum values that I explained before, because we are see only the visible bands, and in the visible bands, the reflectance is lower. Okay, and here I put the name, the position of this Landsat image, pet row, here, and here. Okay, so here is the image that we are seeing. Then I define 3 points, a point of vegetation, a point to soil, and a point of water. Here. I put a zoom. Here, one of my points. In a base map, in the image. And then for each point that I choose before, I draw my points. And I made a graphic, this first graphic here that we can open here using this button. It's important, this button appears in Google Chrome. Sometimes in other browsers, this button doesn't appear. So here is the same graph that I showed you before in the PowerPoint. A point for vegetation, for soil, and for water. So here is the first 3 bands, blue, red, and blue, green, and red. And here we can see the values to reflectance is very low, very low. And then we have here, for green, vegetation low value, and soil higher value when we compare with the vegetation. And here we have a soil with this pattern of a linear, and vegetation with this pattern that lower and then higher values of reflectance. Okay, this point of vegetation that I choose not a strong vegetation. That's the reason that the value is lower than soil, but usually is the opposite pattern. So to define a graph also is a snippet, and we can just put a graph and the graph appears. But we can choose a title, a name for each axis, and color of each line. So for 3 points here, for my variable points here is my 3 points. Is a feature collection, a collection of 3 features that I draw. I choose those points in the image and create a feature collection. So my graph is related with those points that are in the feature collection. So that's the reason that I have only 3 lines here. Then to build this graph, I use this command, chart image regions, because I need to appoint as a region, and then for each point a line. Because if I don't use this option, I choose another option of charts, sometimes I got as a result only one line. It's not my interest. I need one for each point. So to see, I choose also a graph only for water, because water is, when I was preparing this presentation, I saw this blue water and also this brown water, and also other kind of waters. So I decided to see in a graph here. So water, we see in the visible different patterns, and it depends of the color of the water. It's not our focus, but in a brown water, sometimes we have lots of soil particles. And blue and cyan water, sometimes we have lot of bacteria. So depend what each target, we have a different graph here. So this is only to understand each target that we have inside agricultural field. We have vegetation, soil, and water. Okay, so now in the next script, I will we'll calculate NDVI over our area of interest. In this case is Narok. So I show you before how I choose the Narok order using this feature collection and filter by Narok. Then I center map in Narok and select some images. Which images I select? That 2 images that I listed before using the script number 2. That scripts that we have a lot of snippets. So here are the images that I selected before, and here are the same parameters to see the images. The difference now is here. I click to Narok. And clip is a command that we can use only for image. For image collection, the clip doesn't work. So we need other kind of commands to take data only for our interest area when we are working with image collections. It's not in the case right now. So for each image, now I didn't select bands before, like I did here in the script number 3, I select bands, and I didn't click. So here in the script number 4, I didn't select any bands. I choose these bands to visualize, and now I will calculate the NDVI for each image. First, I will calculate for each image repeating the expression. In the next script, I will put this information inside a function. So, for Landsat 9, the red is in band 4 and near infrared is in band 5. And to calculate the NDVI, we need to use near infrared and red bands by this expression. So I use this command, variable image, expression, and then I wrote the expression here, and then I define each variable for the expression. So for near image is the first variable, image, select band 5. And to red image, I select band 4. And then I draw the results. Here is for variable image 2. And here is important to understand is the reason that I put separated for one image and then for another image. Because sometimes people think that the image expression is one command, but no, image is the name of the variable. Here, image 2. Image 2 is the name of the variable. So for variable image 2, I use expression, and then here I wrote the expression. Here I also put, for a reason, the space is sometimes people ask me, maybe my wrong is the space here. No, the space doesn't make any difference. So in this case, I put a space here and here. In this case, I didn't put any space. And the reason is to show for you that the space is not the reason for you get some wrong message. Okay? So I select the images, put each image in one different variable. I draw the images, then I calculate the NDVI and draw the NDVI. So here, run. So here, Narok, then the images, then the NDVI 2 times for each image. Why? Why? Because I decided to put one of them in black and white, and one of them in color. Just to show you that we need to define, here, only that part of color and black and white. So second, color and black and white. My intention here is to show you and talk about NDVI a little. NDVI is one indices that the range is from -1 1, 2, 1. But to negative values are related with clouds, are related with water, and to agricultural areas, the cloud is not our intention to study clouds. And water, usually we can have, but we are interested in the vegetation and soil areas. So when I apply a palette here, we can see vegetation areas. Oops. So here in the base map, vegetation areas. Then in black and white. So higher NDVI values are related with more vegetation, and lower NDVI values are related with less vegetation. And in a palette, we can apply and present in levels of green and yellow. We can choose many palettes. I took one here from the internet. I took a sample from the internet. But we have inside the Earth Engine GINA palettes that we can only by a command line, one line, we can draw the palette without to put all the colors here. Okay. So here is the NDVI for Narok. I hope that you understand that how can I draw this. And was analyzed before. I found some clouds here. Oh, some small clouds here. Can you see? For each cloud, small cloud, we have this shadow here. And there here, another cloud. And shadow. For each cloud, a shadow. Okay, and if I need to study this area, I cannot study because I have a cloud here. I need to use another image. I saw one day a script that the cloud can remove, a script that we can remove the cloud. But when we remove the cloud, we don't have other pixels in cloud to, because, sorry, we don't have another pixels to put here. So we have a hole here if we remove these pixels. Okay, so I will show you now in the next script. How can I get a mosaic, NDVI mosaic, cloud-free, a cloud-free mosaic? So we run first, Narok here, NDVI, but now only one layer. And I took all the Narok here. I don't need 2 images. And I will show for you. So first, I define Narok, center my map. But now is some difference. I selected the entire collection of Landsat 9 here, entire collection for all over the world. Then I filter for February, only February of this year. And then I filter bounds for Narok. Not clip. I filter bounds. Clip doesn't work for image collection, as I told you before. So the command is different, but the result is the same, only Narok here. Okay. Now for the entire image collection, we will apply the NDVI as a function, not for each image. So here, function is the name of the command. Add NDVI is the name of the function. Add NDVI. Image is here. Image I showed for you before. If I put here image 2 and image 2 here, image 2 inside the function, is the same. Okay? But people sometimes think that image is only one command, but no, it's the name of the image that this function create to put the results, and then after apply the results over the entire image collection. So inside the function, the expression to calculate the NDVI is the same that I showed for you before. Okay, same thing. But now we need to rename the results as NDVI. And this result is storage in the variable collection as a new band. So in this function, we calculate NDVI and then put a new band in the image collection with this name, NDVI. So here is the function, and now map is the way to run a function in the Earth Engine. So here I will run my function add NDVI using map over the collection. And then I will create a new collection with this band, NDVI. Okay, now I have NDVI for each image collected in February over Narok. And we have some clouds I showed for you before. But I can apply this command, quality mosaic. Quality mosaic is a very interesting because this command will select each pixel with maximum value inside the image collection, inside my variable collection. So I told for you before, clouds and shadows, the NDVI is negative, have negative values below 0. So for each day that I have cloud, this command will choose another pixel without cloud, because when I have vegetation, the NDVI is higher, is positive. So NDVI mosaic, sorry, sometimes some Portuguese appears. Well, for NDVI mosaic, I took the collection, is here, collection, and apply quality mosaic on NDVI band. Okay? And then I have a NDVI maximum value composite for images over Narok here, filter bounds, Narok. But in fact, if I put to draw here, Narok is not presented with the borders. Are the images, entire images, and then I create, I new variable with my NDVI mosaic here. Select only NDVI. So here I have only one band, one image, in fact, so this is not an image collection, this is an image. And then I click to Narok. Then I draw NDVI with the semi-palette. And it's here that we are seeing here. And that clouds that I found before are not here anymore. So if you have many images, we can make a monthly mosaic or a bi-weekly mosaic. For Sentinel-2, a bi-weekly mosaic is very common because Sentinel-2 is one image for each 5 days, around 5 days. And here we can saw some interesting things. When I put here is the satellite, the base map, and here areas without vegetation are the same that are in the base map. Because I saw here before in Narok, the agriculture fields are in the same place all the time. The agriculture are not getting higher areas. Here in Brazil, agricultural areas are big higher and higher, and the native vegetation are like Amazon are getting lower. But here in Kenya, I found that here in Narok, I found that the areas are not expanding. But maybe I don't know if I am correct. But very interesting. You can talk,
Yes.
please.
Yes. We can see. It's very interesting.
Yes. And then I found, but the agricultural areas are also here in the north of this region here. So in this case, in February, the agricultural fields are with the crops are not implemented yet, I think. But the areas are here. Well, if I found the areas, I took the NDVI without clouds, but in fact, I needed to put this image in QGIS or ArcGIS, so we can export the image. So here, the command export image to drive. Okay, how can I do it? Here, variable NDVI Narok. NDVI Narok is the image. Description is the name that the file. Region Narok. Here, region Narok. And we need to put region Narok. Even the image is only for Narok. We need to put it. Here is scale. Landsat image, the pixels have 30 meters. Here parameter datum WGS84. We need to put this information. It's mandatory. Region, scale, and the datum here. We need to put this strange number here, max pixels. We can put many more zeros, many more. The important is that we cover the image, and then if you have space in your drive, we can export a big image, but you need space in your drive. Then when I run the script, here appears tasks. And we need to enter in task and then submit, run. And now appears the information that I put in the command line before. And then I run here. And then this image will be stored in my Google Drive. This is it's not too big. In some minutes, the process are ending. Here we have a task manager that we can cancel if I need. It's not the case, I think. My internet is okay right now. And then we can go to another script, no problem. My tasks still run here, and I can shut down my computer, and my task continues run here, no problem. Okay. So I talked to you about Landsat images. We can do all these things using Sentinel-2 images are very good images, but considering the time to process here and the internet sometimes made some tricks with us, I choose the Landsat image. To change everything to Sentinel image, we need to understand about the bands, about the spectral patterns and which bands we have in Sentinel-2. Sentinel-2, we have also edge bands that are very useful to monitoring agriculture. Okay, but if we need made some monitoring in small areas, like a startup that sell your products for farmers, we can use these images. It's very useful. But to understand all the agriculture, to understand the cycle, sometimes lower resolution is better. So that's the reason that now we will see about the modes images. Modes is a sensor. Landsat is a satellite. Modes is a onboard of Terra satellite and Aqua satellite, two satellites. Okay. When in the image collection we have MOD, MOD is from Terra satellite. When we have MIT, like this letter, MIT is from Aqua satellite. Okay. Well, now I will run and then I explain. So I took a field to show for you before only over one area, and then we understand, and after we apply for all agricultural areas in Iraq. So here, I choose a point here, our variable out or in now the point, and then I made a buffer of 100 meters. Because each pixel in modes image have a 200 meters around. And then here's almost the same pixel for modes. Okay. Now I center using level 15. because I saw a very small area here. Now we can construct a graph to show the NDVI variations over this area. And when we saw before any explanation, we can see an interesting cycle here, a phenologic cycle, a systematic cycle. Higher values and lower values, higher values and lower values. Lower in January and higher May, here April, so a systematic pattern. How can I build this graph? So first I took a collection, now is an image collection from modes, and in this collection, the NDVI is already calculated. So we don't need to calculate NDVI in this case. I filter the dates. I choose the first image that we have from modes is in this year until now, until that we don't have images from May yet. I choose February here. Okay, and then I filter to this buffer, and select the NDVI already calculated. Now I will define a new kind of chart image series. In the chart before, you use image regions. Now we have a series, a time series. Very interesting to understand, and then we can export the CSV and put in our models if you want. If you have in Kenya some models to forecast the agricultural yield, you can use to export. You can use this data. It's just export. Then I can show for you after. The image collection for chart is this one. Filter for datas and for this point and only NDVI. I show for you. Besides we filter before, we need to put this region parameter, is mandatory. And we need to use a reducer mean. Because if we have, it's not the case, but if we have more than one image over this point for the same day, the graph will present the mean value. And here, simple, I didn't put any kind of title and name of axis that I put before to show for you. We have a graph. We can use this graph without many options, but also we can put many options here. And then I print the chart, and here is I show for you before. And here I download previews because it is easy to share for you. We have here the day and the NDVI value. So for each day that we have image, we have a NDVI value. It's a bigger CSV for all range of days. And then we can export and build better graphics using Python, or can integrate in our models. It's very interesting. Well, we have the cycle. I show for you a systematic pattern, and I show for you in the beginning that we have the weather as a variable that we need considering when we talk about agriculture monitoring. So I show for you now is the ERA 5 and the same graph here, same thing in the script before, but now I took the image collection for ERA 5 monthly and select air temperature and precipitation. Then when I run here, I have NDVI, temperature, and precipitation. And also I can export those graphics here. And I put to draw here just an image from temperature to talk about how we can see this kind of data here. Okay, so I create a variable ERA 5 2 meters because I choose air temperature in 2 meters. I filter for the same days that I filter to modes. I apply a function here to convert from Kelvin to Celsius degrees. Here. So the variable now, the name is add temperature. The function, the name of the function is tconvert. And inside for each image inside the image collection, the function create a tconvert and then select the air temperature and then subtract this 273.15 to convert from Kelvin to Celsius degrees and rename the band and T 2 meters degrees. Okay. Then I add bands here and then apply in my initial image collection using point map command and the add temperature function will run in each image inside the image collection and create a new band and the name is T2M degrees. For the precipitation, the variable is the total precipitation for each month, so any transformation is necessary. So I just took the variable here, total precipitation, selected the same image collection, but I need to separate image collections, one for temperature and one for precipitation to build the graphs. So that's the reason that I call here and here the same. But now I select a different band and filter for the same period. And then I create charts. I put here just to see. We don't need to use this kind of structure. I like to put different instructions, just different structures in the same script so the people can understand that in the JavaScript is different from Python. In Python, if we put this everything together, oh no, now my script doesn't run anymore. But in the JavaScript, in JavaScript, this is not a problem. Oh, what I did. Okay. So I run the script, we saw the graphics, and then I draw only one map, because sometimes I saw people asking, I put to draw and I can see anything. I got a wrong message. Because for a image collection, it's not possible to draw an image collection entire here. Since from 2000 until now, it's impossible. We need to apply a reduction. Or sometimes we choose first, we take it here, era, this one, era, but sometimes we put here first. So the first image it appears here. But in this case, I put min is a reduction, or min reducer, and then the a min value for the entire image collection, and that we are seeing here. Using a palette that I put here, and in this case, I put the name of the colors. The Earth Engine accepts both the code or the name of the colors. But the name of the colors must be in English, not Portuguese, but if you put here white, so the lower values is white and higher values is in red. So here we can see Africa, Antarctica, Southern Ocean, and I am here. It's the time to show for you. I am here. Porto Alegre, here. Porto Alegre. Today is cold. Today is cold. Okay? So we can export the 3 graphics using this button here, download CSV. Or we can choose to download a print of figure as PNG or a graphic editable. Okay. So my last script about agriculture is this one. We apply now the NDVI. We can calculate the NDVI for entire agricultural regions over Narok. So here I define Narok. I center map, but I didn't choose a satellite option here. So the script started from this map, this base map. Okay, no problem. We can change here, but we can put here map center option satellite that I showed for you before. Now to found the agriculture over Narok, I choose this as a land cover. Is an image collection, so I choose the first image. And then I draw here for entire world. Now I need to create a mask. I want to create a mask only for Narok. So this is only to visualize. I don't need to ask to put here again, but just to separate the process. So here to visualize, here to create the mask. The variable landcover LC is my image collection. I took the first image and then I select map. Because if we put here Here we can see that we have a band, and the name of the band is map. And for each pixel, we have a value, and for each value, we have a color. So in this case, we don't need to put a palette before. And for each value, we have a land cover. So in our case, we need this 40 croplands. Okay. So I select map and I put here. For LCE, I need pixels with value equal here, equal 40. And then I click to Narok. And then I put add layer mask. So here. It's important. I didn't put any name here, any name. I just put map add layer mask. So here in layers, it's impossible to find which one. No, it's not impossible. Name is layer 1, layer 2, layer 3, layer 4, in order that then appears here in the script. And then now, from that image collection that I showed for you before, I have only the agricultural areas over Narok. This is when we choose the zoom here, the process run again. This is a very, very high level of processing. So sometimes we spend many times, but I think that is too. I run again. Too lower. Well, I will explain. When I was preparing this script, I spent many times to run this script. Okay, so I visualize the land cover is here. We can draw. Then I create a mask that I waiting for the Google Cloud processing. Then I convert this mask to a vector. And besides as a land cover has 10 meters of resolution, spatial resolution, I convert for a lower scale. And now we can see the reason, the time for processing these tasks is too much higher. So I decided to use a small scale. For a free account, maybe for entire Narok is a problem to process how the solution split Narok in two parts, or maybe choose only the special area that you are studying. I convert the image to a vector because it's necessary here to create a chart, the same chart, but to define the region as the vectors. I cannot define a region here for my chart using another image. I need to use a feature here to define my region. And then so here is the agricultural fields in Narok. I don't know if I put the zoom here, but I will try. Satellite here. So now only for these areas I convert to vectors, and then I create a graph to see the NDVI for those agricultural areas. And now I can observe it, how the agricultural areas behavior during a time of period. Okay. The last script that I prepare for you is Nicolas demand to create an app. I don't know, in Brazil we talk APP. Here, I don't know, app. So the last one, here, here. Oh, I think that my free account is very busy. The script number 8 is very, very high level of processing. Again, so this is very nice script. I hope that it works. Well, the script will take the Narok, take all Kenya, entire Kenya, and then I center here to this Kenya and put satellite options. And as you can see, it's not running, but after to create an app, you have this button here, apps. And then we just, okay. First, we need to build everything that we want to appear in the interface to the app. So Kenya is the name. People will see Kenya here. We'll see the elevation, and here is the legend. And we can choose elevation and also slope. I stand sometimes at a big canyon here inside Kenya. Very interesting. So how can I put? First I put the title for my screen, Kenya. Set a position here. Then I choose a elevation model here, SRTM. Click to Kenya. Our here is now Kenya. And choose elevation. And to slope, I use this command, terrain. And we have slope and we have aspect inside the terrain. I choose only slope. And then I put map add layer. Map add layer slope here, and map add layer elevation here. To draw a legend, I took here as my geoblog, create a legend. I took a snippet and then I adapt. So one legend to elevation, and one legend to slope. This snippet uses the colors of the palette and the minimum and maximum value to create the legend. So it's a lot of lines, but you can take here and adapt. And now the result is, I show for you. Okay. So now, how can I share these results with my colleagues and with people that then don't understand nothing about Earth Engine? Well, I can create an app. Oh, first, if you do something in Kenya and oh please Eliana, help me with my code. How can I help you? You click here, get link, and then we have a link to your script, and you share this link with me or with anyone, and then I can see the same script here and help you if you need. But if you need to share the results with your boss or if the major, they don't understand nothing about Earth Engine. So here we can build an app. With this user, I didn't create any app yet. So no apps to display, create a new app. And then we can, the same user that you have is the beginning of the address. Then Earth Engine app, and then the name of app, Kenya elevation. And then this is the address that we can share with anyone to see the results without the script. So the app will storage in my project in the cloud. Next step. We want the content for the editor right now, or you choose a script. I always choose the first option. Always choose the first option. What I see in the editor is I will share with the people. So next. Now we can put here some logos to personalize it. So sometimes I put the logo of my lab, or you can put the logo of your startup. And then I publish. And now here you share that oh, it's not happy yet. I didn't made, but in some minutes you can click and people can see only the results that we have here without using the code interface, without any knowledge about the scripts and lines. So I prepared this for you. I don't know if we have some problems without the timer. I think that I was late, but I don't know. And I am free. I have many times to answer all your questions if you want. So that's it. Thank you so much. Oh, now it's ready. Well, I think my free space on the cloud are a little bit worried today, but that's it that I have to show for you. Thank you so much, Nicholas, for the invite, and I am here to ask for you all your questions.
Okay, so thank you very much, Eliana. We are really much grateful. I think we have learned a lot today. most of the aspects that we have been preparing for Google Earth Engine curriculum here, you have helped us to address most of them, and this is really grateful. So, from the members, do you have any question to Heliana regarding the project she has said to us? You can type them on the chat, or you can even open your mic and then ask. Yes, Priska, you can open your mic and talk, please.
Hi, Eliana. Okay,
Hello.
so yeah, so some like the demonstration you've done is very relevant to me personally because we usually use those data in other analysis, such as for projects. So my question is there my question is the scripts that you have used. Uh, it looks like a lot is going on there, but I understood what is happening. So is there a documentation that guides someone to do, for example, if I only require the NDVI data, is there a documentation that shows me how what I will need and which functions I'll use? Thank you.
So in the chat, I put the link to scripts. So for each collection, you can um, for here for each sometimes in the scripts I put here the link to the collection. So here we can find the link. This is the for the collection, and sometimes we need to read here and here to understand. And for the comments, we put here uh, like terrain slope here in docs. And then we can find some information about the algorithms, some information here. And also you can put here terrain slope and here terrain slope, Google Earth Engine. And then you found the documentation for the command, and also you can find here a sample that we can copy, put in the here, and understand and see what happens and try to understand. And also sometimes we have lots of information here to see the parameters that we need to put here to the command run. Sometimes this is only one parameter, but for example, for image here, we can have a lots of arguments that we can use and understand better. I don't know if I answer your question.
Yes, thank you.
And Priska, if you need some more information, my email was in the chat. You can ask me.
No, like
Okay.
I've been assisted. Thank you.
Thank you.
Very much, Priska. Eliana. Is there anyone with another question? Because today's session has been very intensive, and I think we have tackled most of the topics in the Google Attention curriculum that we have prepared, and I think this is really nice. And I would like to appreciate the presence of Eliana here because she is one of the Google developer experts, and our community, Google Attention Nairobi, is being supported highly by the Google developer experts. And this is really inspiring. So we hope that one of the days, if you continue participating in this community and working nicely, you would join the Google Developer Experts, SGE experts in Nairobi. So this shouldn't be encouraging to you, to you members, now that you are learning from the experts. So when we were preparing the curriculum, we tried to get speakers to be the best, and you can see that we are learning from the best, and this is really encouraging. So for me, what I would ask Eliana is that I have only one concern regarding the script that you have you had prepared for us. Now, is there a way in which you can call, you can, like, if they are in different, is in one it's in one
Sorry.
repository, and you want to create one project in one in one repository, call all of them. So my question is script to your code. Like, let's say I am here working on a project with you, then you combine it into your one script such that you only read the URL of my code.
Nicholas, I didn't understand well because maybe because the internet connection. You asked about the link for each script, not for all the repository. Is it? Could
No,
you repeat,
no,
please?
okay. So I
Or
was asking. Suppose you are working on a big project, and I am here in Nairobi. Then you are here in Brazil, and we wanted to combine my project section with your project to make one complete project. So is there a way in which you can call my script to your repository and read it without including my code in your section? Got it?
to include your scripts in this repository, you need to share your scripts, and I need to put here. In fact, I didn't understand well because the internet, but maybe if you want to write, or